Yo, what is going on, everybody? It's Brave Cat here, once again with another Frontier Signals update. So I've got quite a few things to cover here, so just bear with me. On the space weather side, we did have a pretty decently large M-class flare, especially with the CME component that came from it, as well as these two periods of geomagnetic activity, which I did learn something as well from Ben's video a couple days ago, or I think yesterday, that I'm sure he's talked about many times, but sometimes it takes quite a few times for information to fully get beat into us. So looking here at this activity with the blue chart here, this is essentially the phi angle of the magnetic field. And so what he was saying was that we have the first period of instability, which was the flip of the phi angle. And that had to do with the heliospheric current sheet, which if we go onto the NOAA, this Enlil spiral forecast thing actually has the Enlil spiral in there. So the heliospheric current sheet is part of this model, and I believe we see that now. I don't know if it's necessarily this here or if I think it's this actually. Either way, so you can kind of see right around here, going into the end of the 15th is when that heliospheric current hits us, and it lines up with that little bit of instability there. But then we have another spike in the KP index happened just today. And so we haven't, that could also is related to the coronal hole that is coming at us. But if we see here on the same chart, we have another part of the chart here where the phi angle does something a little funny. And we do see the solar wind kind of pick up a little bit in the speed. So again, that is related to the coronal hole that's facing us. But then if we look back on here, if we drag this out to approximately where we are now, we are also still kind of in that zone where the heliospheric current sheet is. And then you can also see on here the coronal mass ejection from that solar flare that just happened. So I'll go ahead and kind of show that as well on one of these. So if we go down here, we can see it the best on here, representing the actual plasma coming out. So if you just take a look over here on the left, you'll be able to see that solar flare that happens. So it was pretty spontaneous, pretty eruptive. And so basically that sunspot group is going to be staring at us here soon. So if we take a look at the sunspot graph chart here, model, we can see here on the kind of left border here, looks to be the sunspot group in question. Now, since it's still on the oncoming limb and it's not really totally in view yet, I'm not sure how accurate the magnetic properties here shown are going to be, but we can see there's a little bit of blue in there and some orange, so there is potential for some magnetic complexity in that area. But really we're going to have to wait and see until at least tomorrow when that comes more into view to see what we're going to be up against in the coming couple weeks. So, so far it doesn't look like it's really much here. So that's at least something. But again, these sunspot groups can be kind of unpredictable, even when it looks like it's guaranteed to do something, or it looks like it's not going to do anything at all. Every once in a while, some sort of anomaly happens. Kind of like what happened when we had that monster-sized sunspot group facing us, and that whole sunspot group was basically holding its breath, and instead of shooting off more flares, it actually kind of held back a little bit. So you never really know what's going to go on until it happens, but again, we'll just be monitoring that until it does. So moving on to the earthquake side here, we have had another 6 actually happen up here by the other one. This one is closer to Kamchatka, and it's not too surprising because, Kamchatka's seen a lot of activity in the past year. And so, again, with the volcanic activity combined and the whatever stresses and braking actions are happening in the plate. That is the new activity going on there. And then everything else has pretty much just been filling in the spots that were previously hit, looking into the middle points between those zones. So, and then that translates to here on the West Coast, where we are definitely going to start to see another round of activity coming in from the Northwest. And we kind of see that already happening here on the tremor map. So this is starting to slowly go up, when in the past week or so it's been pretty minimal. Now it looks like we are ramping up again. So there's pressure already coming in here from the Canada border, and we have more slow slip events happening. So we're definitely going to expect to see some more activity going on through here. And then, of course, we have lots of stuff going on here. Most of these spots within the United States, especially Texas, a lot of these are going to be at drill points, fracking zones for oil and gas, where there's, again, perforation points in the crust, allowing for that seismic energy to basically release. So it's a little bit of a double-edged sword. I'm not entirely against it per se, just that's kind of the literal mechanics going on here. So it is, in a way, relieving pressure in these areas, but it's not entirely a good thing. At the same time, it's allowing for more movement and more kind of small breakages happening within these areas, which, again, when looking at the middle points, could lead to more activity in the quiet areas. And that last part there, I mean, that's really more of a kind of speculation on my part, but that's kind of the way it seems like. So, and just to kind of tie things into the volcanism here, we've had a pretty decent blast coming out of Sabancaya, Peru, which is here. And so, you know, this little string of volcanoes here, there's actually lots of volcanoes in all these mountain ranges going down South America. So this is right here, kind of in this little hook, this little bend in the plate. So we do see some activity going on here. Let me just turn down the rings, and you can see in that hook and that bend in the plate, that's where we also see a lot of the activity seismically going on. And then this letter D in the Dutch Sense overlay is also stands for deep earthquakes. And so we do see deeper activity here as well. As you can see, these are slightly raised higher off the globe. Not as much as the ones that we see down here in Fiji, but they are still a little bit deeper. And that's to do with probably likely all the magma chambers in here. So we're only looking at about 100 kilometers or so, which isn't as, I guess, dangerous or whatever, as influential as the 400 to 500 kilometer deep earthquakes that happen over here. So that's kind of what we have there. Now, there hasn't been a whole lot of other volcanic activity going on, but the activity that we do see, especially in Central and South America, seems to be more or less kind of ramping up a bit. So once we start to get closer to the 30,000 foot mark and beyond, then that is when that is more or less considered, you know, pretty significant volcanic activity there. So just to keep another eye on that. And, you know, this list hasn't really changed a whole lot. Pretty much have more or less the same amount of active and minor activity related locations here. And the list is looking not really too big for today, so that's something, I suppose. And then, well, let's see, I want to flip back here, look at the Italy quake map on the same website. And I've been meaning to mention this, but, you know, you see on this graph where we have the 3 spikes, and then going into this year, well, because it's so early in the year, it goes down. But if you see, there's 54 magnitude 3 earthquakes so far, and we're not even 2 months in. And last year there was 200. So we're already a quarter of the way to matching the magnitude 3 level activity that was going on last year. So I could definitely see by the end of it, we're going to see another spike similar to these over here, because there's been quite a bit of an influx kind of all across the board. And let's see if we, again, flip back. So going back to the NOAA, there was a little bit of a graph down here. So we have the sunspot number and then the radio flux progression. So on the sunspot graph here, and this goes back quite far, we can see that overall, let me just kind of zoom in a little bit here, the number of sunspots has been on average less than what we've seen in previous cycles. But if we look at the radio flux progression here, and this is just basically comparing the last solar cycle here, you know, compared to the last one, we've had a lot more intense of a solar period. Even though there's been less sunspots, basically the ones that we do have are a lot more intense and have had bigger flares come out of them than we've seen previously. So I just thought those charts there were kind of notable in that different comparison. That's, again, kind of similar to what we see on the tremor map, where it's like, you know, we've had more or less the same amount of tremors, but they seem to be increasing in intensity. And then that also kind of correlates to the volcanism, which I don't have the full data sets on these. You know, this is a kind of bigger topic of research here. And sometimes the way volcanic eruptions are categorized can be a little bit vague or a little bit, I guess, not super consistent, where if you have a continued eruption, if you have multiple blasts from the same eruption, it usually doesn't really make its way into the data like that. So it'll all kind of combine into one event, basically. So it's a little bit harder to look at previous volcanic activity, and that is also very prevalent on the chart that I have. Where is it here? The chart that I have from the Smithsonian. So if you look at the data table for eruptions, you know, it looks like more or less we have similar activity going throughout most of these years, even though the types of eruptive activity can fluctuate a lot more. So it just seems to be, you know, a little bit of a gray area there in terms of that. And then I guess one last thing here. Again, I'm just kind of flipping around back and forth because there's just a lot of different scattered things here. So in regards to these two 6.0 earthquakes and some of the types of earthquakes that happen based on the movement between the plates, we have the beach ball moment tensor thing here. And so this is something that's going to take me a while to fully get a grip on. But we have a bit of a graph here kind of showing what these mean, at least the kind of basic ones here. So we have the strike slip shear events, which is most of the ones that you'll see going all along the west coast. And then you have the one we're looking at here for these sixes, which would be the reverse thrust compression events. And so I'm starting to wonder what kind of correlation could be made between, so let's say, compression events going on over here and the strike slip events going on over here. And I don't believe there's really any information on this because, again, trying to correlate earthquakes over a large area is still, unfortunately, a very frontier level science, even though it's actually, it should have been something that should be common by now of how earthquakes relate to each other. So I kind of want to do some research and my own kind of digging into seeing if certain events on one side of the plate can help influence or cause events on the other side. So if we have the plate, this is kind of my theory, if we have the plate over here compressing, for example, is that going to influence the strike slip events that we see over here? And that's just kind of one example. Now I was trying to look to see what kind of things are going on over here. I guess I can look up a couple of them, but for the most part I was not seeing any of the beach ball diagrams over here, so I don't know I don't know what kind of earthquakes happen over here. There's got to be some of them over here, maybe some sort of map somewhere that has that information. But again, that's kind of something that I'll be slowly kind of trying to observe and see if I can make any relevant correlations, because that sounds like kind of a neat idea to see if there's anything going on with that. So anyways, that is, I guess, about it for today. One last thing, or a couple last things I wanted to mention here. So I did upload my YouTube origin story, and so that'll be the kind of featured video on my channel for a while for new and older viewers. I think that'll more or less kind of give a pretty good explanation on what's been going on in this whole 10 plus year journey on here. That's been ups and downs, lefts and rights, corkscrews, backflips. Yeah, I can't even name the amount of stuff that's happened. But, and then so the last final thing here, I do have, did I close out of it? Well, again, I do have the other project I was working on, which is my solar insulated box. So I've already made a post for that on the Slower Killshot Network, but I do want to somehow integrate that project in a different page here on my website at some point. I think once I get this layout more or less locked in, and once the web page goes live, which will kind of be like beta 1.0, let's just call it, then I'll be able to add a lot more different content on here and have some other fancy pages in here. So I just wanted to really quick show just one screenshot from this project. So this is a solar insulated box, meaning we've got plastic and rubber to basically help against the solar-induced induction that can potentially happen during very severe solar events. So essentially, if you're just using a regular Faraday cage or box that has metal in it, well, that metal could actually be predisposed to some sort of induction with metal arcing happening, and that's not good. So anyways, I'll just have that kind of wrap up here. Hope y'all enjoyed this one, and I'll catch you all in the next.